morning. Let's see how we're doing today. This would be Friday's assignment. For so happy Friday. So we assigned you your stuff, and we're just going to go with some review. And I just want to see how you're doing. Okay. It's hard with me not in front of you. I get that and all that kind of stuff. So we're going to look at some stuff here and kind of go through this. So just a little review. Just make sure we're okay. Make sure you have your periodic table in front of you. Again, if you got to pause this and go back to it, it's okay. So remember, on your periodic table, the top number is going to be your atomic number. It simply measures the number of protons. The protons determines what kind of atom you actually have. All right. Remember, all atoms are neutral. This is not going to change today. Okay, because what we're going to do today is called something called isotopes, and we're going to show you how that works. But the idea is that they're neutral. So your positives, your protons, and your negatives, your electrons, have to equal each other. That's going to be your top number on your periodic table. Bottom number on your periodic table is going to be your mass number of protons and neutrons added together, all things with mass. Now, we really haven't talked about why this is. Electrons are really, really, really tiny things. We're not going to go into the actual number, but they're so small, they're like insignificant. It's like throwing a deck chair off the Titanic. Nobody really cares. Okay, so we don't write down those things on there. We don't worry about the electrons on there because we know the electrons, we know what they are because they're equal to the charge, but the masses don't matter. Your neutrons are not actually written on the periodic table, right? Because that number is your protons and neutrons added together. So if I look at boron, okay, boron says 10.811 at the bottom and has a 5 on top. That means I have 5 protons and I have 5 electrons because they equal each other. And I simply subtract those two to get my neutrons. That's all you gotta do. So take the mass number 11 for boron. In fact, just round. We'll talk about where the decimals come from today. Okay. And then subtract your proton number there. And 11 minus 6, or 11 minus 5 gives you 6 neutrons, okay? So that's counting the pieces and making it up. So what I want you to do, and you were supposed to send me those pictures or whatever, and I'm recording this before, right now it's actually Monday while you guys are probably still asleep. All right, I'm recording all of these ahead of time, so hopefully I've gotten your pictures, or at least you figured out a way to send me the pictures of your atom drawings. So I could give you guys credit just for trying early on. That's all I care about. But let's see how you did, okay? Now, again, excuse my drawings as we go through this. But the idea is look at your drawing for carbon, okay, and look at your drawing for chlorine, because this is what I want to go over today, just to make sure we are all on the same page, okay? If yours do not look like this, and I'm not talking about the sloppiness either, I'm just talking about if yours don't look like these pieces here, let's just try to understand why. So what I want you to do is I want you to write the symbol right here, just like you have on your periodic table. So again, yours is a little flipped. I write this is the traditional way, so I'm sorry. So yours might look like you have carbon, and then you guys have the 6 on the top and the 12 on the bottom, so don't confuse you guys too much. All right, I just do this by the way mine normally is. But no matter what, the smaller number is always your proton number, 6 protons. Because atoms are electrically neutral, you have 6 electrons. Your positives and your negatives, protons are positive, electrons are negative, they are always equal to each other, okay? Now, this number right here is your mass number. I wrote it up here because that's typically how it's written later on, but that's okay. Your mass number is here. And you simply subtract these two. 12 minus 6 gives me these 6 neutrons right here. So that's how you figure out these numbers, okay? And don't worry about the 666. We're not going to anything worse on that. So where do they go? In your atom drawing. So again, hopefully you've done these. And hopefully yours look like mine. And if not, it's okay. Fix them right now, all right? Because we're going to use these drawings with Monday's stuff, with something called ions. Okay, we'll talk about that as we go through this. So, inside your nucleus, you have 6 protons and you have 6 neutrons. So I drew a little nucleus right here, put 6 plus and 6 ends. Now, in middle school, some people might have drawn like 6 little plus signs and 6 little zeros. I don't care how you do it. I don't care how anybody else did it. It does not bother me at all. Okay, just make sure you have all that kind of stuff in. Okay, I sneeze here, apologize, we got something going here. Now, remember your rules, okay? Remember rules for electrons, these energy levels, these things on the outside, okay? Everybody remember the numbers that they do? All right, well, if you don't, that's what I'm here for. All right, remember you can have 2 in the first, you can have 8 in the second, you can have 8 in the third, you can have apologize. Trying to write on Microsoft Paint is not the easiest thing in the world. Okay. Okay. Now, 2, 8, 8, 18, 18. Now, if we continued on this, it would be 32 and 32. Now, what I want you to notice is there's 1, 2, 3, 4, 5, 6, 7 numbers, and there's also 7 rows on your rows on your periodic table. And if you look, hydrogen and helium make 2. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon make 8. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon make 8 as well. So that's why all that kind of stuff. Now, we don't get into the why all that kind of stuff is called hybridization. It's not important for you guys to know that. But I always fill low to high. 2 in the first, 1, 2. Now, I can fit 8 in this second one, but I only need 6 total. I've already had 2 here. I put 4 more here. All right, gives me my 6 electrons on the outside. Okay. So this is what an atom of carbon will look like always. Okay. Now, why do I spread these out? Well, these are both negative charges here. You guys remember that 2 negatives coming together will always repel each other. That's supposed to from a long time ago, like in magnetism and stuff like that. So these 2 electrons want to get away from each other as far as they possibly can. Well, these 4 electrons want to get away from each other as far as they possibly can too. So they will spread out around the circle as much as they possibly can. Okay? And so this is what carbon is going to look like. 2 electrons in the first energy level and 4 in the second. And remember, you always follow your rules. 2, 8, 8, 18, 18, 32, 32. I think this is covered in section 3 in chapter 14. So how I do it and how the book do it, they kind of skip around a little bit, but it all is going to equal out when everything works out together. Okay? So this is what makes this atom an atom. You have 6 protons. You have 6 electrons. They positives and negatives equal each other, and then these 2 happen to match up. Now let's go over to chlorine. Chlorine's number 17. Again, you might have them flipped on you're going to have them flipped on your copy, and that's okay. But this 17 represents your number of protons. 17 identifies chlorine as chlorine. Okay. Sorry.
Attention, everybody. The office copier is down. Do not print to it. Print to the library.
Okay. Sorry about that. So you have 17 protons. Now remember, protons and electrons equal each other. Positives and negatives equal each other. So it's 17 and 17. Now this number up here on your periodic table is 35.45. If you guys wrote this as 35, if you guys wrote this as 36, either one doesn't matter for right now. It doesn't matter. We just round to whatever you want to round to. Just make it a whole number. This number minus this number, remember, this is your mass. All right? 35 is your mass. These 2 have to add together to get to this mass. So 17 protons, 18 neutrons. You just subtracted those 2, and that's how you got your neutrons. Okay. Now remember, protons and neutrons always go in the nucleus. So there's my 17 plus and 18N, drawn as well as I could with this Microsoft Paint. It's okay. All right. Now, okay, you guys saw my drawings on the boards. It's not that much different, and that's okay. All right. So again, we fill our rows. 2 in the first. Try to put those 2 there. Then you have your second one. Now remember, you can fill up to 8 in there. Well, now I need more than that. So I just put my 1, 2, 3, 4, 5, 6, 7, 8. I don't care if you spread them all around. It's okay. All right. I know more than you. No offense. All right. And I know that these are going to pair up after you get to 4 because they just have to. It's like you guys sharing rooms in your house. It's just kind of how that goes. Okay. So I have 2, 4, 6, 8 in that second level. So you can remember that second level can hold 8. All right. Now the third level can also hold 8. So I can have 2, 4, 6, 7 because I only need 17 total. So look, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, look at your drawings. Okay, I don't have drawings for all of these pieces and all of these parts. Look at your drawings. Sulfur should only have 1, 2, 3, 4, 5, 6 in that last outer shell, outer energy level. It should be missing this one. If you guys drew argon, it should have 1, 2, 3, 4, 5, 6, 7, and then 8. Another one right here if you for the argon one. Now, obviously, these numbers are going to change when we do different things. I just wanted to show you a couple that I wanted to make sure you were drawing. So if you are still having trouble with that and need some help with it, there's lots of good resources online about how to draw atoms and all that other kind of stuff. Or you can just email me, shoot me one. Draw me aluminum. All right, if you look at aluminum, aluminum is 27 as your mass, 13 as your top, so you should have 13 protons, 13 electrons. 27 minus 13 gives you 14, should be your neutrons. And when you draw it for aluminum, just look at your drawing. You should have 2 in the first shell, 8 in the second shell, that's 10, and you need 3 more, so you have 3 more in that shell. Okay. Now, we didn't draw calcium. Okay, we didn't draw calcium, so let's make a new one here. Okay, we're just gonna discard and be fine. Okay, so let's draw calcium. Let's just make this nice and big here. Again, this is just review. This is kind of what we would do in class, right? Do this part, and I'll teach you about isotopes in a second. So here's calcium, Ca. We never do that. Okay, 20, and then 40 is its mass. Again, just bear with me here. Okay, so I'm just going to skip right to the guts. Here's my nucleus. You should have 20 positives. Again, it should not take me this long, but it does. And 20 neutrons, because those minus those. Now, you know how many electrons we should have? That's right, you should match this. And again, I feel like I'm Dora the Explorer talking to you guys like you can actually answer me. So there's 20. I should have 20 of these. So I'm going to do this. Just try to do this as best I can here. Let me see how these things are going to go. I'm going to draw 4 shells here only because, again, I know what's coming here. Okay, so remember, first shell can hold how many? 2. Second shell can hold 8. Now, if you want to write them this way as well, I'm okay. Third shell can hold 8. I'm just cutting to the chase here. You should have these many circles around here. So that's 8, 16, and 18. So I would need 2 more. So your last shell would look like this. Just try to save time. Okay, and that's all you got to do. And you would do that for the rest of them. I'm never going to give you like element number 118. You'd be drawing circles forever. That's going to give you an idea about what it's going to be, because as we get into Monday's lesson, it's this last shell that matters. It's this last shell that matters. So hopefully you have your drawings done. Hopefully you're doing okay with all that. All right, and seeing how this works. I just want to go with this over with you today. Okay, so that's just a review on your drawings. Take a look what it is. If you're still really confused about it, ask me today. All right, shoot me an email. All right, it's the whole point of this learning process here, is that if you're not sure about what goes where, like you're not sure where the 20 come from, not where the 20 came from, whatever, you're not sure why there's 20 electrons out here. All right, just make sure you're okay with that. Okay, so just a review on this, and then in the next video